So as you can see on the screen here, our goal for this lesson and to highlight again in this video is that we will be able to use a given ratio to find the point that divides a line segment proportionally into that ratio that we are given. So let's see an example and we're going to run through it really slowly all together. So here we have a problem. And if we take a second and we read the problem, it asks us to partition or split up or divide the line segment in a ratio of 3 to 2. So I'm going to circle that because that's important here. We have a 3 to 2 ratio. That's how we're going to be dividing this line segment. This means on one side of the point, there will be 3 parts of the line segment. And on the other side of the point that we're looking for, there will be 2 parts. Once again, that comes from the 3 to 2 ratio. Whatever the point that we're looking for that divides the segment in a 3 to 2 ratio, there will be 3 parts of the line segment on one side of it and 2 parts of the line segment remaining on the other side. So our first step is to determine the number of parts that we're going to split this line segment into in total. And since there's a 3 to 2 ratio, there's going to be 3 parts on one side and 2 parts on the other side of the point. So in total, that will be 5 parts. 3 plus 2 equals to 5 parts. And in order to figure out the total number of parts on that you're going to be dividing the line segment into, if it's given in ratio form, all you have to do is add the 2 parts of the ratio together, and that will tell you the number of sections we're going to be dividing the line segment into. Step number 2 is we're going to determine the vertical and horizontal change. Basically, that means we're going to determine how many spaces up we're moving from one endpoint of the line segment to the other endpoint, and how many spaces left or right we are moving from one endpoint of the line segment to the other endpoint of the line segment. So as you can see here, if we have a line segment, like a slanted one like we have here, if we just draw a line up and across from one endpoint to another, we can really easily count the boxes to see what the change is, what the vertical change is and what the horizontal change is, because we have a right triangle here. So in this example here with the endpoints that they gave us for Y and Z of this line segment, if I count up, there are 15 boxes. So our vertical change or our change in Y, because vertically is the Y coordinates, is 15. And if we count side to side, there are 10 boxes, 10 units. So our horizontal change, which we also call our change in X, because left and right is our X coordinates, is 10. And something to keep in mind, as it says here at the bottom of the screen, is that it makes sense for both of these values to be positive in this specific situation because our line had a positive slope. It started off lower and it was going up higher. If our line segment had a negative slope, we could expect either the vertical change or the horizontal change to be negative. But since we have a positive slope, it makes perfect sense that both of these numbers, the change in X and the change in Y, should both be positive. Step number 3 is to take that change in X and the change in Y that we just found in the last slide and divide by the number of parts that we're dividing the line segment into. In slide number 1, we determined that since we're splitting in a 3 to 2 ratio, that's 5 parts in total, 3 plus 2, that we're dividing the line segment into. So we found that our vertical change, our change in Y, was 15. So if we divide that by the number of parts that we're splitting the line segment into, we get 3. And our horizontal change was 10. That was our change in X. And if we divide that by the number of parts we're dividing our line segment into, we get 2. So what we can do now is using this that we just found, we can actually split our line segment YZ into those 5 parts. The 3 tells us our rise, and the 2 tells us our run. And that tells us if we start at one of the endpoints, so if I start at point Y, if I go up 1, 2, 3 boxes and over 2 boxes, I can mark down that point as one piece that I'm splitting my line segment into. To find the other sections of the line segment, to split it up into those 5 parts, we can go up by 3 again and over by 2, up by 3 again and over by 2, up by 3 again and over by 2, up by 3 again and over by 2. Notice how we now found 5 equal parts, well, along this line segment. We have 1, 2, 3, 4, 5 parts that we just partitioned this line segment into. Just as it says here, you should have 5 parts. 1, 2, 3, 4, and 5. Next, what we are going to do is actually find the point that we were looking for. The question asked us to divide the line segment in a ratio of 3 to 2. That was the ratio that we were given to work with. Point P, which is the point that we're looking for, we are naming it point P, should split the line segment so that there are 3 parts on one side of the point and 2 parts on the other side of the point. Once again, that's from the 3 to 2 ratio. The 3 means that on one side of the point, there's going to be 3 parts of the line segment. And the 2 means that on the other side of the point, there are going to be 2 parts of the line segment. So we can find which point is the point we're looking for. If I go over to this first point over here, I'm going to ask myself, are there 3 points, 3 other parts on one side of the line segment and 2 parts on the other? No, there's only 1 part here on the side. And on this side, there's 1, 2, 3, 4 parts. So that's not the ratio I'm looking for. That's not my 3 to 2 ratio. If I go to the next point over here, 1, 2 parts on one side and 3 parts on the other. But since there's 2 parts to the left and the 3 parts to the right, that would be a 2 to 3 ratio with the 2 written first. So that's not the ratio I'm looking for. I'm looking for 3 to 2. Let's check out this point over here. 1, 2, 3 parts on one side, 1, 2 parts on the other. That's the 3 to 2 ratio I'm looking for. And you can take a look at the illustration here. This is the point we're looking for because there are 1, 2, 3 parts of the line segment on one side, and there are 1, 2 parts of the line segment on the other. That's a 3 to 2 ratio. So we found the point that we're looking for, and we can write down the coordinates of that point. And if you take a look, that would be -1, 1, 2, 3, just as is written over here. So that's how we can divide a segment proportionally using a given ratio graphically. As we know from class, we can also do this algebraically. So we're going to go a little bit deeper into that and do that slowly all together. So this is the same problem, but we're going to just solve it another way algebraically. So same question. We have the same line segment with the same endpoints as before. And once again, we are going to proportionally divide the line segment in the same ratio of 3 to 2. So the first thing we're going to do is we're going to take our ratio and we're going to convert it into a fraction. Our fraction needs to take into account how many parts we're going to be dividing the line segment into. As we talked about when we looked at how to graphically complete this question, to figure out how many parts we're going to be dividing the line segment into, we can add the 2 parts of the ratio, 3 plus 2 to make 5. So that means the fraction that we're going to be using to find our point is going to have a 5 in the denominator because there are 5 total parts that we're dividing the line segment into. And there's going to be a 3 in the numerator because it is a 3-to-2 ratio. And you can use this format anytime you have a ratio and you want to solve the question algebraically. You can add up the 2 parts of the ratio. That will be the denominator because that's how many pieces we're splitting the line segment into. And the first number in the ratio, which would be the 3 here, would be our numerator. Now that we've identified the fraction that we're going to be using, we are going to take the fraction and we're going to multiply by the change in x and the change in y, which is our vertical and horizontal change. So we do need to find the change in x and the change in y. So you can either do that graphically like we did before, and that's what's shown here. You can count the boxes vertically and you can count the boxes horizontally from one endpoint to the other. Or, as we talked about in class, if we want to do this completely algebraically, you can take the y coordinates from our 2 endpoints and subtract them, y2 minus y1, to find the change in y. And you can also take the x coordinates from the 2 endpoints, x2 minus x1, and that will give you the change in x. And you should find the same change in x as 10 and the same change in y as 15. Once we have our change in x and our change in y, we can multiply by the fraction that we found on the previous slide. And as you can see here, 10 times 3 over 5 gives us 6, and 15 times 3 over 5 gives us 9. Now, all we need to do is take the values that we found on the previous slide, 6 and 9, and we need to add them back to our starting endpoint, which would be point y. So if we take point y has an x coordinate of -7 and a y coordinate of -6. On the previous slide, horizontally, we got 6, and vertically, we got 9. So to the x value of point y, we are adding 6, and we get -1. And to the y value of our starting endpoint, point y, which is -6, we are adding 9, and that gives us 3. Those are the coordinates of the point that we're looking for, the point that's going to divide the line segment in the 3-to-2 ratio. And that's the point -1, 3, which, if you remember, is the same exact point that we found doing it graphically before. So to summarize the steps that we just did over here, we can write down the same procedure that we talked about in class. I'll write for the x coordinates and for the y coordinates here, although you can do them both at the same time. So change in x, change in y. So first you need to find the change in x and the change in y. Then you need to multiply by the fraction. That's for both of them. And then finally, add result to starting x coordinate. That means the x coordinate of the endpoint you are starting at. And for the y coordinates, you're going to add the result that you found in the previous step to the starting y coordinate. And those are exactly the steps that we talked about in class. It's 3 steps. The steps for the x coordinates will give you the x coordinate of the point that you're looking for, the one that divides the line segment into your given ratio. And doing these 3 steps for your y coordinates will give you the y coordinate of the point you're looking for that will divide the line segment into the ratio that you're looking for. So just to summarize, there are 2 ways to determine a point that divides a line segment proportionally, algebraically and graphically. You can choose whichever method works best for you. You do not have to do it both ways. You can pick whichever way that you like. Hopefully this video helped to clear some things.